All right, so let's talk a little bit more about linear equations. Okay, remember linear equations are equations of straight lines. Okay, that's why the word line is in linear equations. They're equations that represent straight lines on a graph. Okay, so a linear equation can take on a lot of forms. What you need to know is you're always going to have an independent variable. Remember, we're calling independent variables IV, and this is usually x. Okay, and it's x to the first power, meaning you can't have x squared, you can't have x cubed. Those are no longer going to give you straight lines. And it's also going to give you a dependent variable, which in most cases is going to be y. And y is also to the first power. Now there's a very special form of linear equations that we are going to be discussing. This is called, let's do some blue, slope-intercept form. Okay. Now the way that this is set up, when something is in slope-intercept form, you've actually seen this. We did this in the last lesson. It's going to look like this. Y equals m times x plus b. So many variables. Now, what does each one mean? Y is your y coordinate. This is your dependent variable. Okay. X is your x coordinate. It's also your independent variable. You already knew that. You know that when you write out coordinates, they're written as x comma y. Okay, that's what these x's and y's represent. Whatever x you plug in is your x of your coordinate, and whatever y you get from your dependent variable after manipulating x is going to be your y of your coordinate. You've all dealt with this, you've all seen this. Now what about m? Now we've dealt with m, and it takes on a few different terms. One of which is the rate of change. It's also been known as the unit rate, and it can also be called the slope. Another term that you're going to hear a lot when dealing with m is rise over run. Okay. Each one of these means the same thing. Okay. The rate of change, some of you might think of it as a scale factor. I get it. Okay. It's the number that you are multiplying your independent variable by. It's also considered a coefficient. Okay. It is the coefficient of x. And then finally, b. B is your y-intercept. What in the world is a y-intercept? Your y-intercept is your y-coordinate of the point where your graph crosses the y-axis. Oops. So again, y equals mx plus b. Your x's and y's, they're all going to be representing the different coordinates that are on the line that this equation gives you. Okay? We don't usually put in values of x and y, we just leave them as x and y in the general form of the equation. The only things that we're actually going to give value to when we solve for linear equations is going to be m and b. Okay, these are the only two variables that when you write the general form of your linear equation that are going to have numerical values. So m and b. Remember, m is your rate of change. It's considered the unit rate or the slope or the rise over the run. Later on, as we're talking about rise over run, I will explain to you why it's called rise over run. And then b is the y-intercept. In other words, it's the y-coordinate of the point where your graph crosses the y-axis. So let's look at a graph. Okay, let's look at a graph. Let's go here. Let's go to Desmos. Graphing calculator. Let's say that we have y equals 2x plus, let's do 0 first. And then I'm going to show you what happens when I change that number. Notice that when it says y equals 2x plus 0, your graph crosses at 0, 0. It crosses the y-axis at 0. Well, what about if I change that to y equals 2x plus 1? Now it crosses the y-axis at 0, 1. Okay, your y-coordinate changed. It's the same as a number here, where I'm adding 1. What if I did y equals 2x minus 2? Now my y-intercept is negative 2, which is why you cross the y-axis at negative 2. Okay? And I'm going to do one more. Y equals 2x minus 4. My y-intercept is negative 4 because it's minus 4. And my graph crosses at 0, negative 4. Okay? If I ever want my y-intercept, it's given to me in the equation. If it just says 2x, that's the same thing as 2x plus 0. I don't need to put plus 0 there. So I know that this graph is going to cross the y-axis at 0, 0. This one's going to cross at 0, 1. This one's going to cross at 0, negative 2. And then this one's going to cross at 0, negative 4. Okay? Now, what do I mean by slope? What do I mean by rate of change, rise over run? Well, think about it. If I tell you that in this case, 2 is the number in front of x, remember, x is next to or being multiplied by m, which we called the rate of change, the unit rate, the slope, or the rise over run. If I tell you that m equals 2, well, 2 is the same thing as 2 over 1. So if I tell you rise over run, what does that mean? Well, notice here my slope is 2, or my rise over run, or my rate of change is 2, m equals 2. This means that if I pick 2 points, okay, their ratio is always going to be 2 or 2 over 1. Well, to go from 0 to 1, I need to go rise. Rise means go up or down. I go up 2. I go over 1. Remember, this is 1 because it's in the middle. I can even do this. So I go up 2 over 1. Rise over run. Rise over run. My rise is 2. My run is 1. I go up 2 over 1, up 2 over 1, up 2 over 1. Okay? And it works every time. Up 2 over 1, up 2 over 1. All of my points are going at a steady pace of up 2 over 1, up 2 over 1. What if I made it negative 2? Notice what happens to the graph when I change this to a negative. Notice the direction it's going in now versus now. What happened? It flipped, right? Instead of sloping upwards from left to right, now it's sloping downwards from left to right. So my m, which is my slope, not only tells me how steep my graph is, but if it's positive or negative, it tells me what direction it's going in. When it was positive, it was sloping upwards from left to right. Now that it's negative, it's sloping downwards. And now what does my rise over run mean? Well, if I pick a point, let's say negative 2 over 4, or sorry, negative 2, 4. If it's negative 2, that's negative 2 over 1. That means my rise is negative 2, which means I'm going to go down 2, 1, 2, and to the right 1. Down 2, 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 to the right 1. And I can keep going. Okay? This tells me how my graph is changing. That's why it's considered the rate of change. So again, when I tell you that m is the rise over run, that means that regardless of whether I have a whole number, if it's a whole number, let's say I tell you m equals 5, that's the same as 5 over 1. This is the rise. This is the run. If I tell you m equals 2/3, now this is the rise, and 3 is the run. Remember, when I'm telling you rise, if my rise is positive, I go up. Okay? If my rise is negative, that means I'm going to go down. And my run always goes to the right. Okay? Always. My run is never negative. You're never going backwards on a graph. Think about it. If I have m equals negative 2 over 3, this negative, regardless of whether it's placed up above, in the middle, or below, is always going to be down 2 and then to the right 3. Doesn't matter if it's written this way, or if it's written this way, or if it's written this way. Okay, you're still going to go down 2 and to the right 3. So what if I'm given an equation? How am I supposed to graph it? What are my steps? Simple. Let's say your equation is y equals negative 4x minus 7. First thing I want you to do, ID your b, which is your y-intercept. Well, if I do that, b is -7. So I'm going to make a table, and it's going to tell me exactly what my coordinates are going to be. First one, x and y. Remember, b is when x is 0, that means y is -7. And I can check that because -4 times 0 is 0, minus 7 is -7. If I tell you that x is 1, well, -4 times 1 is -4, minus 7 is -11. And then if I plug in 2, -4 times 2 is -8, minus 7 is -15. This gave me 3 points that I can plot, and then all I have to do is connect the dots. So let's say that this is what I have. Here we go. I had 0, 0, -7. I had 1, -11. And I had 2, -15. I'm just going to double check that. Good. So where are all these points? They're right here. And what did my equation say? My equation said y equals -4 minus 7. Y equals, if this is correct, these points should be aligned and the line should go right through it. -4x minus 7. Oh look, the line crosses all of these points. Okay. So if I give you an equation, you should easily be able to give me the line by just plotting 3 points. How do I plot 3 points? Just pick a value for x. I picked 0, 1, and 2. I got -7 as the y for 0, -11 as the y for 1, and 2 or -15 for the y of x equals 2. And I plotted them, and then I just connected the dots. Okay. That's it. I'm done. And the same thing happens if I have a table. I should be able to go and look at my graph and make sure that my graph works. Okay. So in the next couple lessons, I'll show you how to go from a table to an equation. I'm going to show you how to use 2 points to get an equation, and I'm going to show you how to use a graph to get an equation. Okay. So this time we went from the equation, we made a table, which we've done before, and then we used the equation to make our graph. Okay. Again, all we did was pick 3 x values, which gave us our y's. Okay. If you need a brief review of that, again, all I did was I said, what if x is 0? I didn't really need to do that one because it was already given to us. Because if x is 0, then -7 has to be my y. But I can try it anyway. -4 times 0 minus 7. -4 times 0 is 0. 0 minus 7 equals y, which means -7 equals y. So my coordinate here is 0, -7. If I said x equals 1, now I do -4 times 1 minus 7. -4 times 1 is -4 minus 7 gives me -11, which equals y. My coordinate is 1, -11, just like I got here. And then if I wanted to figure out what I would get for 2, I would plug it in and solve. Okay, that's it. I'm just going to substitute these numbers for x, get my y's, and then graph the points. We should all know how to graph points by now. This was taught in 6th grade. I'm sure it was taught before that as well. And always make sure to close your coordinates. That's it for this video. Should you have any questions, please let me know.